Hi, you guys. Welcome to Skill 3. Today we're going to be talking about how to apply the application of solving systems. So what we've been doing the last few classes is we learned 3 methods to solve systems. We use graphing, elimination, best when we can get the coefficients of one variable to add to 0. Substitution, best when we can isolate one variable. So we're going to keep these 3 skills in mind as we move on. So you want to make sure you have your notebook ready to take notes. The page numbers are numbered at the bottom. So let's go ahead and get started. Miguel is renting a car for the day. They're offering 2 options, A and B. And the price depends on how many miles are driven. So we see that our input is miles driven, our output is cost. Question A, if Miguel drives the car 50 miles, which option costs less? So look at my 50 miles. I see that it crossed here and here. So option B would be $40 if I go over to cost. Option A would be 30. So how much less does what is the price difference? The price difference is $10. And option A would be the cheaper option. For what number of miles driven do the 2 options cost the same? So I'm looking for where they intersect, which would be here at 150 miles. If Miguel drove less than that amount, which option is cheaper? So if I'm doing less than 50, my red line is the cheaper line, which is my option A. If I drove less than 150. If I drove more than 150, we see my B becomes the cheaper option. So once again, you want to be taking these notes. In 1 month, Heather rented 2 movies and 6 video games for $40. The next month, she rented 5 videos and 3 games for $25. Find the rental cost of movies and games. So when we do these, I need to identify my X variable and my Y variable. I'm going to do X is cost movie, cost of game. I'm going to go ahead and highlight this 2 movies, 6 video games, 40. That's going to be one equation. And this 5 movies, 3 video games, and 250 is going to be my other equation. So with my green information, I get 2 cost of movies plus 6 video games cost us 40. 5 movies plus 3 video games cost us 25 off my blue equation. So now I have 2 equations. The way this looks like it's set up, I'm going to choose elimination because I think I can be able to get the 3 and the 6 or the 2 and the 5 to add to 0. So I'm going to go ahead and multiply, make my y's add to 0, multiplying everything here by a -2. Then when I add down, I get -8x plus 0y equals -10. So it's able to eliminate my y. So my movies cost $125. However, I'm not done because I still need video games. So I can go ahead and plug my X value of 125 in. So I end up with my video games costing $625, which makes sense that video games are more expensive than movies. This is a similar problem. The car company is renting tables and chairs. 2 customers rented both tables and chairs last weekend. The chart shows all that. We're going to write 2 equations. The first is 8 chairs, 4 tables for that much. 8 chairs, 3 chairs, 2 tables for that much. Think about how silly it is that someone rented 3 chairs, but it's okay. And then this asks us to write an equation for both of these. So let's go ahead and write our green one first. And this tells us X is the cost of chairs. So 8 chairs plus 4 tables cost us 53. Here, 3 chairs, 2 tables cost us 24. Now it wants us to solve that. So we can choose what method we want. I am going to suggest we use elimination again. If you wanted to do substitution, you could. I'm going to try to eliminate my y's again, just because I can easily get my y's to cancel out. Sorry, this should be, so if you want to pause the screen and try to solve this by yourself, go ahead and pause the screen. So we see that X is 2.5, or the cost per chairs is 2.5. I still need to solve for my Y value though. We end up with Y equals 8.25. An air traffic controller is tracking 2 planes. To start, plane A is 2,873 feet, and plane B is taking off. Plane A will gain 25 feet per second, and plane B will gain 80 feet per second. So, let's identify our inputs and our outputs. So I'm going to say our output is altitude, and our input is going to be altitudes in feet, and our input is time and second. I'm going to go ahead and highlight everything relating to plane A. So it starts at that, and then it increases by that. So let's use that to write an equation. So plane A is starting at, its altitude is starting at over there, it's plane A. This is where it's starting, and then it's increasing, which is our x value. Plane B is just taking off, but it increases by that. So we write an equation for that. Plane B is at y equals, it's starting at 0, but then it's gaining um, 80 feet per second. So when I look at these two equations, it's asking me how many seconds before the planes are at the exact same altitude, and then what is their altitude. So how many seconds, this is wanting the x value, this is wanting the y value. So we need to solve this. This is going to want the x value, and this is going to want the y value. I can plug this y value in where I see that. So I'm going to do y equals but I know y is the same as 80.75x. Now I can combine like terms. Or I can divide both sides. Combine like terms and divide both sides. My x value equals 52. So after 52 seconds, they will be the same. But I don't know at what height that is yet, so I'm going to go ahead and plug that into y. And I end up with a y of, in 52 seconds, they will both be 4,199 feet in the air, which is crazy. Okay, I want you guys to take a second to read this problem on your own. So we have a situation with two buses, and they leave town 243 miles apart at the same time and travel towards each other. So let's just make x rate of bus 1, y equals rate of bus 2. So they're 642 miles apart, and each of them, if each of them traveled 6 hours, they would eventually get there because they'd meet in 6 hours. So we can set up this equation. So that's our first equation, and then we know bus 1 is 17 miles slower than the other. So bus 1 is 17 miles less than the second one. So I'm going to use elimination, or substitution here, I'm going to put this y value into this. And now I'll take the time to solve for my y equation. I can combine like terms. So I know that y is 62 miles per hour. That doesn't answer my x yet, but I can go ahead and put a 62 into here. That should be a 17. And my x is, my rate of my first train is 44 miles, or first bus is 44 miles per hour. Okay, we have one more problem. So last year Josh had $30,000 to invest. In one account it paid 10%, the other account it paid 6% interest. And he got 2,280 in interest. How much he invests in each account. So our x and y is going to be amount in account of 6%, and y is going to be amount in account that gets 10%. So I'm going to write two equations. I'm going to write one equation just based off of how much he invested. So we know that the amount each account has to add to 30,000. We also know he got 10% in one account, 6% in the other account, and that got a total of that amount. So 6% of what we put into x plus 10% of what we put into y equaled the total amount of interest that he got. And now we can use any sort of method to solve this that we want. I'm probably just going to use elimination and multiply everything here by a negative 0.1. And keep this row the same. If you chose to do it a different way, that's just fine. I was able to eliminate my y. And now I can find the value of my x. So I get 18,000 in the account that had 6%. This has not answered my question on how much is in the other account though. But because they both have to equal 30, I can see that it's 12,000. Okay, that's all for this lesson. Good job.